So the next section we cover is about concavity in the second derivative test. So what is concavity and why do we care? What this all relates to is really the shape of a graph. But to understand concavity and its definition, let's look at two separate functions. The two functions I want to look at here are f of x and g of x. Notice both f of x and g of x have positive slopes. In other words, they are increasing. So that's what I've written right here. It says both functions are increasing, so the derivative of both functions is positive. But these two functions have very different shapes. One of them opens up, one of them opens down. The first function, f of x, think about the derivative, which is the slope of the tangent line. The slope, because it's increasing, is positive, but as we move from left to right, it's getting more positive. So the derivative, or the slope of the graph, is increasing. The derivative is increasing. So I'm going to write that down right here. F prime of x is increasing. The derivative is getting more positive, or the slope is getting more positive. Versus g of x here, if we look as we go from left to right, it's positive because it's going up, but it's getting less and less positive. So in other words, f prime of x is decreasing. So, what do we have for the definition of concavity? Let's go over and look at that. It says anytime a graph is concave up, its derivative is increasing. That's what we saw in f prime of x right here. Its derivative is increasing. Likewise, anytime it's concave down, its derivative is decreasing. So, concave down, the derivative is decreasing. So what does it turn into? What's an easy way to remember it? When I think of concave up, I always think of a cup. Concave up, I think of cup. A cup, in this case, what we're looking at is the shape of a U. Kind of looks like a cup. Any aspect of this graph is concave up because my derivative is increasing over its entire domain. When I think of concave down, I think of a frown. Concave down is a frown. Any aspect of this graph or shape of this graph is concave down. So, if a derivative is increasing, then the derivative of the derivative must be positive. So if a derivative is increasing, the second derivative must be positive. F double prime of x is positive in this case. If the derivative is decreasing, then the derivative of the derivative, which is the second derivative, must be negative. Again, the derivative is decreasing, and anytime a function decreases, its derivative is negative. So if the derivative is decreasing, the second derivative must be negative. So anytime your second derivative is positive, you're concave up. Anytime your second derivative is negative, you're concave down. This is absolutely key to understand. We have when the first derivative is positive, it's increasing, while when a second derivative positive, it's concave up. When your first derivative is negative, it's decreasing, while when your second derivative is negative, it is concave down. So let me write those all in a little chart for you to memorize. This is something that I can ask questions on the test. Okay, so here I've created the charts for you. So we have what's the relationship between a derivative and a function. The derivative positive means increasing. The derivative negative means decreasing. Again, the derivative tells us when a function is increasing or decreasing. The second derivative of a function, when it's positive, tells me my original function is concave up. And when the second derivative is negative, it tells me the original function is concave down. So anytime someone asks about increasing and decreasing, you're dealing with the first derivative. Anytime someone asks about concave up and concave down, you're dealing with the second derivative. That's exactly what these boxes are about right here. It says test for concavity. So first thing you have to do is find the second derivative, find out when it's positive. Anytime it's positive, the graph is concave up. And anytime your second derivative is negative, it's concave down. So what are we going to do? Very, very, very similar to the sign chart method. Instead of finding where the first derivative is equal to 0 or undefined, we're going to find out where the second derivative is equal to 0 or undefined. We're going to create the number line, determine the intervals. We're going to After we've determined the intervals, we're going to use a test point. But now notice the very, very, very important point here. The only difference between the previous one is instead of plugging it into the first derivative, we're plugging the test point into the second derivative, and this will tell us our concavity.